Okay, hello everybody. I hope that I am audible to you. So, but yeah, still, if you have any doubt, you can ask. I hope that I am audible to you. Yeah. So, from my side, my voice and video is very clear to you guys. But yeah, still, if you have any, you can say, problem in watching the lecture, you can tell me. So, first of all, good morning, all of you. And as you know that it's our lecture number 6 of the classical thermodynamics, right? In the previous 5 lectures we have covered almost all the basics of the classical thermodynamics, right? So hopefully today we will start the laws of the thermodynamics, right? So I hope that everything is clear to you from the last lectures. But yeah, still, if you have any doubt, you can ask, right? So please tell me if you need any conceptual clarity. If you need any conceptual clarity. Yeah. Let's discuss the previous thing, guys. Very quick. So we have this last time we have discussed the state equation of the state, right? And with the help of indicator diagram, we understood the meaning of state, and through the state, how we basically explain the process actually, right? So if we go from one state to another, that is called my process. Okay. Yeah. After that, we have discussed the point function, right? So point function is nothing but it is the basically the property which is depend upon only the initial and the final state. It is independent on the path taken. Very simple. And all the properties are the point function, right? And point function, or you can say the property, all the properties of point function, and the property which are point function, we can define them with the help of the exact differential, right? Like dv, dt and dp. Okay. Path function is a different thing. In the path function, that particular quantity is path dependent. If you switch the path, the value will be different. They are not depend upon the initial and final state. So as you can see in this diagram, all these three processes, processes 1, process 2, process 3, all these three processes have the same initial and final point, but still the value will be different. Why? Because if they are following different path, then these values have the different value. After that, we go through the thermodynamic equilibrium. In the thermodynamic equilibrium, we basically discussed, or we basically checked about 3 equilibrium: mechanical, thermal and chemical, right? In the mechanical, what is the meaning of mechanical equilibrium? That there should not be unbalanced forces. In all the directions, forces, the net force will be 0 actually. Mechanical equilibrium means the net force will be 0. I can write this also, the net force is equal to 0. Thermal equilibrium is the temperature of the gas, piston and wall of the cylinder must be same. Means that everything, whatever we define the system, the temperature of that system will be same at every air. Chemical equation means that there is no driving force, all the equilibrium, and what I'm saying, that you can say that no driving force is there, no reaction, or you can say that no formation of the product is happening, right? So it may be possible that the rate of the forward reaction rate is equal to the rate of the backward reaction. will be equal. So in that case there will be no driving force. So it means that overall I can say that reaction is not moving forward, or even it is not moving in the backward. If all these equilibrium exist simultaneously, then we can say that yeah, system is in the thermodynamic equilibrium. After that guys, we discuss the work done by the gas, which is a very important thing, right? So work done by the gas is basically a very simple, that del W is equal to PdV, right? Is it clear to you? Or I can say W is equal to integration PdV. After the integration, if we know the initial volume and the final volume, then I can convert this integration, or you can say by solving this integration, I am getting W is equal to P delta V. So P delta V is my, you can say, not the general formula. It is the formula of considering that pressure is my constant quantity. Pressure is my constant quantity, right? I'm clear with this, right? So in the last class we have taken some examples. Right? With the help of that examples, we understood this thing. Okay. Now, through this experiment, through this gas cylinder experiment, you can see that gas is basically expanding here, and this, or you can say that with the help of this expansion, we plot the PV graph. Okay, we plot the PV graph. So we find a curve, this kind of curve I'm getting, and this is my formula. W is equal to P integration PdV. The significance of the integration is area under the curve, and if the integration is between P and dV, then we can say mathematically it is the area. This integration shows the area under the PV curve. So area under the PV curve gives me the work done by the gas. Okay, is it clear to you? So if we have curve, let's suppose, right? Yeah, we will discuss today the how we can calculate the work done by the gas if we have the PV graph. We will discuss that, but yeah, you should have the knowledge that if we have the PV graph, then by finding the area under that curve, I can calculate the work done by the gas. Very simple. Okay. So this is basically the fine work done by the gas, right? And as you can see that this is the path basically we are basically you can say that we are following, right? So my work done is my path function. We already talked about it. Now I'm basically today also we continue these important points, and in these important points we have discussed the sign convention. So work done by the gas considered as positive, work done on the gas is considered as negative. If volume is constant, then there will be no work done, right? Is it clear to you? Okay, if pressure is constant, this is my quantity of the work done. In another form, it is nR delta T. Okay, if my pressure is the function of volume, then how we can calculate the work done? So this is the function of the volume, right? And this is how we can calculate the work. Next, if my pressure is the function of temperature, and let's suppose this is the function, P is equal to alpha T square, where alpha is the constant. So I give you that dV is equal to minus nR divided by alpha 1 divided by T square dt. Yes, Mohammed. Have you done this homework? You calculated or not? You calculated or not? dV, after this dV, have you calculated, Mohammed? whatever the homework I give you, please attempt it. It is only for you if you want to crack this examination with the good rank, right? Dedication is very, very important in this examination. I am saying this again and again, right? So this is nothing like that you are not doing the required things and you can crack this examination with the good rank. No, this is not possible at all, right? Whatever the teacher give you an assignment, please attempt that assignment. If you are not able to do it, just do it, right? Just do it. So yeah, I have given you this homework. I hope that you guys are attempted this your homework. But yeah, still, if you did not attempt this, please, जो भी मैं आगे आपको homework दूं, please उसको attempt करें, right? So yeah, so pressure is a function of temperature, guys, and we have the P is equal to alpha T square, and we have to calculate the work done by the gas if my temperature is changing from T0 to 3T0. Okay, so this is my formula. We know that work done is equal to integration PdV. But now, if you pay attention here, then now P is the function of temperature, and here integration is in the volume. So by putting P is equal to alpha T square will not is basically solve our purpose. Why? Now because T is variable here, and dV, it means that change is in the volume also, and T is basically variable here. So what should be our mathematical approach here? Our mathematical approach will be something that we have to convert V into T, right? We have to convert V into T so that there will be a consistency in the one parameter, and we can solve the further expression, right? Is it clear is it clear to you? Okay, now understand this. So now we have dV expression, right? So my dV is equal to minus n r divided by alpha 1 by t square dt. This is my dV, right? But see, now we have the relation between the dV and dt, and I think that our purpose is now solved. So what I want to calculate the work done by the gas. Okay, so what is the general formula? Del W is equal to P into dV, right? So what is the del W, guys? Del W is equal to P, right? What is the P? The formula for the P is alpha T square. It is given. What is the dV? This is the value, and this is in this value, this is in the dt. So I think our purpose is solved here. So put the dV value here. It is my minus n r divided by, it is alpha t square into dt. So alpha t square. So now del W is my nothing, but it is my minus n r dt, right? By integration I can write W is equal to integration minus n r dt. What is the initial temperature? T0. What is the final temperature? 3T0, right? So from T0 to 3T0 we have to calculate the work done. Okay, so W is equal to minus n r, integration of dt is t, so it is my 3T0 minus T0. What is the value, guys? W is equal to minus 2 n r T0. This is the answer. Please check this and if you have any doubt you can ask. Okay, great. Yes, can we move forward now? Can we move forward now? Okay, great. So that was my fourth point, right? Okay, now please put the point number 5. Point number 5, right? So what is the point number 5? See, so it is obvious that W is equal to integration P dV, right? What is this? It is my area under the PV curve. Area under the PV curve, right? Area under the PV curve. Okay. So let's suppose I have a case. Just understand this thing, right? Just understand this thing. Let's suppose, guys, I have a PV curve like this. This is my P and this is my B, and this is my point A, and this is my point B, and the process is like this. Process is we are going from A to B, right? We are going from A to B. So if we want to calculate the area under this curve, then this is the area under this curve. This is the area under this curve, right? So this area basically is showing the work done by the gas. This is basically the work done by the gas, right? And it is my, first of all, it is my positive or negative? It is my positive. Why? Because as you can see here, that process is A to B, and from A to B there is an expansion. From A to B there is an expansion. There is an increment in volume, right? Is it clear to you? When there is an increment in volume, it means it is the work done by the gas, and work done by the gas is my positive, right? So very simple, very simple. If you know that there is expansion, then work is my positive, right? Expansion means the increment in the volume. Okay. Yeah, Mohammed, please tell me, what do you think about this graph? I'm plotting the graph, and please tell me, what do you think about this graph? That please tell me the sign of the work done. Please tell me the sign of the work done. This is my PV graph, and this is my A, and this is my B point, and this is the process. Please tell me the sign of the work done. Or you can say, can you tell me that in this process, by seeing this graph, can you tell me that work is done by the gas or work done on the gas? Yeah. in this third example also, please tell me about the work done. It is V. Okay, it is the V, it is the P, and the process is A to B. Please tell me. Okay, work done on the gas. Good. Now tell me in the third graph. Yeah, by the gas. In both the cases, by the gas. Okay, in the first case on the gas, and in the second case by the gas, right? Okay, just now please pay attention here. So most of the students attempt the mistake here. Most of the student, right? That's why I plot this graph. That's why I always explain these things with the help of the graph. Okay, see, if you are saying that in this case there is a work done on the system, if work is done on the system, it means the volume is decreasing. Yes, it is so obvious that this graph is the decreasing slope. But can you, if you pay attention here, that at the A point, at the A state, this is the volume, and at the B state, this is the volume. So at the B state, the volume is larger as compared to the volume at the A. Yes or no? Array, if this is the volume at the A and this is the volume at the B, and we can clearly see that VB is greater than VA, it means as the process proceed, my volume is increased. If my volume is increased, then it is for sure it is the case of the expansion, and if it is the case of expansion, it means the work done is positive. If volume is increased, then it is the case of expansion. It is the case of positive work done, right? Is it clear to you? So here also work done is my positive, right? Yeah, but Mohammed, do not worry. You can say 95% of students made a mistake here, right? Is it clear to you? Just focus on the arrow. Where is the arrow? Okay, here also the process is from A to B. Okay, if you can see here that at the point A, see, just pay attention at the volume axis. Just pay attention at the volume axis, right? Do forget about the pressure axis. So at the point A, this is my volume, and the point B, this is my volume, right? And yes, in the work done, which is area under the PV curve and area under the PV curve on the axis of the V, right? In the graph 1 and in the graph 2, we are plotting this graph on the volume axis. So here also we are plotting we are taking the area under the curve on the volume axis, right? Yeah. So at the point A, this is my volume. So let's suppose it is my VA, and at the B, it is my volume. It is my volume at the B. And clearly you can see here that my VB is less than VA. It means that from this arrow we can say this is the case of compression. So volume will be decreased here. If volume is decreased here, it means the work done by the gas is negative here. Work done by the gas is negative here. Right? I hope that these things are clear to you. Okay, next. Tell me the fourth case. Tell me the fourth case. Just pay attention and keep calm and just try to understand the things. This is my P, this is my V. So it is very important to see the axis, that where is the P and where is the V. V is at the x-axis or V is at the y-axis. So first thing is this basically, which is you have to figure out, right? Okay, so process, guys, what is the process? Process is, here it is my A, so process is going from A and it is going up to B. After that it is going B to C, right? And it is going from C to D. Okay, so this is the process actually. Tell me what is the overall sign of the work done? What is the overall sign of the work? It is positive or it is negative? It is positive or it is negative? Positive. Okay, let's see. See, so this is the basically graph. Now just try to understand it. Here I am explaining each and everything, but in the examination we will not have that much time that we explain in our mind each and every process, figure out and then give answer. No, that is our war situation. That is basically, that will be our kind of war situation, right? And in that situation we should act very quickly, right? Is it clear to you? So I am explaining here each and everything very in detail, but yeah, after practicing or after you can say knowing everything, we can conclude any concept in one line, right? So if you are seeing the process A to B, so from A to B, that this is the volume at the A and this is the volume at the B, right? Is it clear to you? So there is a volume expansion here, so area under this curve. So whatever the area is under the AB on the volume axis representing my work done, please mark my word, right? What I'm saying that area under the AB on the V axis is my work done, and this is my positive work done, because volume is my increasing. Overall my volume is increasing, so it is my positive work done. So this is my work done, right? Now just understood the process B and C. just understood the process B and C. If you are pay attention here, so from B to C there is a constant volume. At the B to C the volume is not going to change. It means in the process B to C my volume is 0. My volume is 0. Now from C to D, here you can say this is the volume at the C, and at the D this is the volume at the D. It means volume is decreasing. If volume is decreasing, it means area under the CD on the volume axis is negative. If you are facing any problem, please let me know. Please let me know what I'm saying. So from C to D my volume is decreasing, so my work done is negative. So this is my work done, which is my negative. Is it clear to you? So the work done is here. First it is my positive and then it is my negative. It is clear to you? So positive and negative work done gives me what? 0 work done. So from C to D, the graph, the positive graph and the negative graph basically, or you can say the positive work done and the negative work done will cancel out each other. Yes or no? So what you can say the graph we will have, or you can say what area we are left with. So this is the area basically we left with. This is the area we left with, right? So this is the area, guys, we left with. Okay, and what is this? This is my positive work done. I hope that I am clear with this graph. Yes, Mohammed, please let me know. I am clear with this graph or not? So this is how you calculate the work done in the graph. If you will see any question of the work done, and if you have the PV graph or VP graph, then this is how you can calculate the work done. Right? It is clear to you? So why I delete this graph? Why I delete this portion? This portion is deleted. Why? Because if we see the work done from A to B, that is the positive work done. So in this graph it is a positive, and due to C and D it is my negative. So by adding positive minus negative, it is basically, you can say, giving us the 0 value. That's why we neglect this portion. Now overall we are left with this area. Right? Is it clear to you? Okay. Next, fifth point, which is also very, very important. Fifth point. Yeah, please tell me if you see this kind of graph, PV graph, and there is a process A to B, and this is my process B. Okay, first of all A to B, and secondly from B to A. What is the work done? What is the work done, guys? It is positive or negative? Yes, Mohammed, tell me. What is your comment? It is my P, it is my V, right? And we are interested to calculate the work done from A to B. 0? Very good. Yes, very good. So guys, yeah, actually it's almost 10 years. It's almost 10 years that from 2000, you can say 16 itself, I started teaching, right? And in these 10 years, I figure out about the students, means you can say the 80 to 90% I know that at what level student can make mistake, right? If you will see whatever the content I'm giving you, whatever this is the discussion, you will not find anywhere this discussion, anywhere. Because these are the things which I'm telling you, which I bifurcate, which I put into the content. This is basically that thing which is कहीं ना कहीं मैंने भी ऐसी mistakes की हैं during my preparation. I also made these kind of mistakes. And I see that most of the students in these past 10 years, I see that most of the students made this kind of mistakes. That's why I bifurcate those mistakes. That's why I you can say directly take all these, you can say, mistakes in form of the content, right? So please pay attention here. Very simple, A to B. See, just I'm giving you a very, you can say, clear concept. Just think about the one process, plot the area under the curve on that process. After that, see, it is my positive and negative. This is it, right? This is the process. So just forget about B to A. Forget about the B to A. Just consider only A to B. So from A to B, what is the area under the curve? This is the area under the curve. From A to B, volume is expanding. Yes. So work done is positive. So this is my positive. Now B to A, because we have to calculate the overall work done. What about the B to A? Sir, B to A is my, what is the area under the curve? B to A, this is the area under the curve. It is negative or positive? It is negative. So this yellow and this line, positive and negative, gets cancelled. So area under this is my 0. Whatever, what area you are left with? Only this area. Only the area enclosed in this curve, right? And what is the overall work done? Positive is the overall work done. Am I right this? Am I clear with this? Yes or no, guys? Am I clear with this? So if you will find any cycle, if you will find any this kind of cycle, guys, then work done by the gas is nothing but it is the area of the loop. Area of the loop. So this is the area of the loop, right? So what I'm saying, what I told you guys, that yeah, through the you can say 0 point, through the basics, I calculated here the work done, that how this work done is the area of this loop, right? But in the examination, there is no requirement of doing all this thing. If we concluded already that if you will find any cycle, then the area under the area of the loop will be the work done of the gas, then just remember like this. Is it clear to you? This is the basic, you should know this. But yeah, after all these things, if you have these information in your mind, then you can calculate the question very quickly. And this is what we want. This is what we want. I hope that this is clear to you. Let's suppose that the sign of the cycle will be different, or you can say opposite. Okay. Let's suppose P and B. This is my A to B, right? This is my A, and the process is something like that. So tell me the work done and its sign. How to calculate the work done and what is the sign? Please tell me, guys. Please tell me. Yes, Mohammed, tell me. If this kind of graph we are having, then please tell me the work done. Please tell me the work done. How to calculate mathematically the work done? Also tell me the sign. Also tell me the sign. Negative. Very good. Very good. Very good, Mohammed. Yes, it is negative. So first of all, if we'll talk about the to calculation of the work done mathematically, then calculation will be same, that area of the loop. Area of the loop will be the work done, right? So if we have the value of A and B, then we will just find the area of this loop. That will be the value of that work done. Again, what is positive and negative? It will be negative. It will be negative, right? Why it is negative? Yeah, Muhammad understood the things, but yeah, I'm explaining here for others that from B to, the process is from B to A. So from B to A, area under this curve is this, but it is my negative. This is the value of the area under the AB curve. Sorry, under the BA curve, right? But it is my negative, right? And from A to B, this is my area, which is my positive. But yeah, overall is negative is greater, right? And negative is my having larger value as compared to the positive, right? So what is the overall value? Negative is the overall value. Okay, so I hope you understood all these things, right? Okay, next, what is the point here? Okay, next point, 6th point. Let's suppose we have this kind of graph. This is my P and this is my V, and this is my A, this is my B, right? This is my point C. Let's suppose this volume is V1, and at the point B, at the point C, volume is V2. What is the work done of the gas? What is the work done of the gas? What is the work done of the gas? It is 0 or any value, because we started from the A and we end up with the A. Okay, yeah. What is the arrow? From A to C and C to A. Sorry, C to B. From A to C and C to B, this is the process. So what is the work done? The work done will be 0. Is work done will be 0 because we started from A and end up with the B. Volume is the same, or anything, or anything else. Please let me know. Please let me know. So most of the students think like this. Yeah, Mohammed, can you tell me? Can you tell me, Mohammed? Very quickly. So most of the students think like this. Yeah. That the process is started from A. The initial volume is V1. And the final volume is V1. It means volume is not going to change. It means that volume is not going to change. Is it clear to you? And if volume is not going to change, then work done will be 0. Yes? So this is the thought process most of the students have. But as I told you guys, work done is my path function. It is not my point function. In the point function is depend upon the initial and final point, but path function does not depend upon the initial and final point, right? Is it clear to you? How it is possible that you are doing a process from A to C and C to B? If you are seeing here, then overall volume will be changed. If you see here, overall volume will be changed. Let's suppose this is my cylinder piston system. From A to C, my volume will be increased. So it means that from A to C, let's suppose this is the A, and by increasing volume, the piston is here and it is at the C. Volume is going upward, piston is going upward. After that, we are doing some work on it. Again, it is on the B. So this is this much of the work done you have already done on this, or you are getting on this. So how the work done will be zero? No, work done will not be zero. Is it clear to you? So it is very simple. From A to B, this is the area under the curve. From C to B, area under the curve, but the negative, whatever the area you have left with, the net area will be this. Approach will be same. There is no requirement of thinking about anything. Just see area under the curve. There is expansion, take positive. There is compression, take negative. And if there is any positive and negative graph, just neglect that, or you can say just minus the negative negative work done from the positive, and whatever you have left with, that will be my overall. Work done. Is it clear to you? So here work done by the gas is my positive, right? So there is no requirement of thinking, you can say the other things. Just remember one thing, that area enclosed, or you can say area of the loop will be my work done. So this is my area which is enclosed in this half loop. Okay, is it clear to you? Now this is my question based on everything whatever we discussed here, and please try to calculate this question. This is my P, this is my B. Okay. Okay. So चलो मैं इसको ना एक काम करता हूं, इसको हम नेक्स्ट पेज पे करते हैं. ओके. So please write down the question. This is my PV graph, right? And this is something like that. Pressure is in kilopascal and volume is in cubic centimeter, cc, right? here at this point, the value of the pressure is my 2, and at this point the value of the process is 1. At this point the value of the volume is my 3, and at this point the value of the volume will be 6, right? Is it clear to you? And the process is like this. This is the, you can see the sign of the process. So process is your clockwise. Okay, yeah, please tell me, what will be the work done? You have to calculate the work done by the gas. So in our mind, if it is very clear, see, if you pay attention here, we take 2 cycle here, this cycle and another cycle, है ना? एक और हमने cycle की बात की थी, right? So if the cycle is my clockwise, can you see here? If my cycle is clockwise, my work done will be positive, and if cycle is anti-clockwise, then work done will be negative. It is very obvious, right? So we can you can say note down 2 points. So you can say we can remember 2 points. If the cycle is anti-clockwise, my work done will be positive, and if my cycle will be negative, anti-clockwise, then work done will be negative. So I can say that for the clockwise, it is my positive, and for anti-clockwise, it is my negative. So this cycle is my clockwise cycle, then whatever the work done we will have, that will be my positive work done. So this is, we are done with the sign. Now how to calculate the work done mathematically? So how to calculate? Very easy, that area enclosed in the loop. So this is the loop here, and we have to calculate the area. First of all, just decide that this, whatever this structure is, this is circle, this is ellipse, or what, right? We have to figure it out, right? So how to figure it out, guys? See, if the, you can say this diameter, or you can say this diameters of this thing, or you can say this line is same. Mathematically, if the value of this line is same, it means the diameter is same. It means it is circle, or if it is different, then it is ellipse. So from here, the value is 3, and here the value is 6. So this is having the, what is the value? 3 is the value. So from this, what is this total 3? What is the half of it? It is my 1.5 cc. What is the value here? Means that from this value, the radius is my 1.5. Figure out this radius. If it is 1.5, then for sure it is my circle. So yeah, from here it is my 1 and it is my 2. So what is the length of this line? Length of this line is 1. What is the half of the 1? 0.5. So from here to here, the value is 0.5. So it is my 1.5, it is my 0.5. It means that this is not the circle, it is my ellipse. Is it clear to you? And you have to calculate the area of the ellipse. Very simple. So work done by the gas is area of the ellipse. Right? So this is called side A, and this is called side B. And area of the ellipse. What is the formula for the area of the ellipse? It is my pi A into B. Pi A into B. Is it clear to you? If it is circle, then we apply the formula for the area of the circle. Right? So it is my pi. What is the value of A? A value is 0.5. 0.5. Is it clear to you? Is it clear to you? So 0.5. So 0.5 is in, you can say 0.5 is in the kilopascal, right? So if we you can say calculate it in the SI unit, then for the kilopascal, just multiply 10 raised to power 3 to make it into the Pascal. Okay, B, what is the B? 1.5 cc. 1.5, it is my cc and it is my Pascal, so we have to calculate it, we have to convert it into the meter wala unit, right? Meter cube. So for it we have to multiply with the 10 raised to power minus 6, right? So this is the guys, and I think it is my 0.75 multiplied by 10 raised to power minus 3 joule. This is the basically answer. This is the basically answer. So very simple. Just if you are you can say if my question is related to the loop, then if the process is clockwise, answer will be positive. If the process will be anti-clockwise, then it is negative. And area enclosed, just calculate the area enclosed in that loop, that will be the magnitude, and with the help of the clockwise and anti-clockwise funda you can get the value positive or negative. If this type of question you will find in the GATE, then one option will be plus 0.75 into 10 raised to power minus 3. Another option also will be minus 0.75 into 10 raised to power minus 3. So it means that सिर्फ और सिर्फ मैग्नीट्यूड निकालने से भी काम नहीं चलेगा, ठीक है? If we have only the value of magnitude, it is not sufficient. We have to calculate the sign also. Yes. I hope that you are okay with this. I hope that you are okay with this. Okay. Please note down this and tell me so that we can move forward. Okay. One more slide I need for the work done. Okay. So we have talked about the formula for the work done, how to calculate the work done for the gas in different cases. Now one important thing for the work done is, so guys, work done is basically a transient phenomena. Work done is basically a transient phenomena. You will say, sir, what is the meaning of transient phenomena? Just note this statement, you will understand. See, so work is done only during the process. During the process. While crossing the boundary. While crossing the boundary. The course of transition, right? During the course of displacement. So work done is transient phenomenon. Work is transient phenomenon. Please note down this and let me know. I'll explain it that what is the meaning of this statement. what is the meaning of this statement. Yes, हो गया note? Are you done with this? So see, very simple. Just tell me guys, tell me one thing. Is it possible that let's suppose this is my P and this is my V, and this is any state of the system where we know the P1, V1 and T1, means we at this stage we have the values of P, V and T. Can you find the work done at this point? Please tell me, can you find the work done at this point? Can you find it? What is the work done on this point? Please tell me. No. Very good. No, we cannot find the work done at this point. So this is what the statement is. Work is done only during the process. If there is a process is going on, guys, in that case, in that scenario, we can calculate the work. We cannot calculate the work at any particular point. There is no sense of the calculating work done at any point. No. We are interested only in the work done if there is a process. If there is a crossing of the boundaries. At the initial lecture, we talked about the closed system and open system, where we discussed that heat is crossing the boundary, work done is crossing the boundary, like that. Okay, is it clear to you? So if there is any displacement, if there is any, you can say, process, right? In that case only we can calculate the work done. Otherwise we cannot calculate the work done. We cannot calculate the work done is a wrong statement. There is no sense of the work done at any single point, right? If we are going from this point to this point, from A to B, then yeah, there's a work done is making any sense. So this is basically called transient phenomena. Okay, this is the only meaning. It is called transient phenomena. It is clear to you? Okay. Now, second thing. Please put a heading, quasi-static process. Quasi-static process. Let's understand this. What is the meaning of quasi-static process? Okay. So in the thermodynamics, guys, quasi-static process means the process that is basically happening infinitely slow. The process is happening infinitely small, guys. Sir, what is the meaning? See, as you know that we have only the single example is enough to understand the whole thermodynamics, that is the cylinder piston assembly, right? This is a very good example, guys. So this is my cylinder, this is my piston, and process is something like we want to compress the gas. we want to compress the gas. Let's suppose this is my piston and a gas is filled into this cylinder. A gas is filled into this cylinder. Right? So we basically compress this gas. Right? What is the meaning of quasi-static process? See, so we have the two choices. One choice is we can sudden compress this gas, right? If you basically, yeah, tell me one thing. Okay, just understand like this. Yeah, please tell me. Yeah, Mohammed, tell me, if I compress this gas suddenly, then in this case thermodynamic equilibrium is, you can say, is the thermodynamic equilibrium is possible. Let's suppose at the initial state there is a thermodynamic equilibrium. At the first say, at this initial stage, my thermodynamic equilibrium is basically established here. Okay, is it clear to you? Can you tell me, if I suddenly compress this, that equilibrium will disturb or it is maintained? It is disturbed or it is maintained? It is disturbed or it is maintained if I suddenly compress this gas. Very simple to think about it, guys. If I suddenly compress this, it means huge amount of force I have to apply. Mechanical equilibrium will disturb here. Only one equilibrium will disturb here. Then there is no requirement to think about the other two equilibrium. If one equilibrium is disturbed, it means that we are not in the thermodynamic equilibrium condition. So if you are doing any process suddenly, then for sure thermodynamic equilibrium will be disturbed. Right? Is it clear to you? If you disturbed any process suddenly, then any of the equilibrium, for sure they will disturb, and the condition of the thermodynamic equilibrium will disturb. Right? Instead of sudden compression, do one thing: compress this with you can say very negligibly small value. Right? It is clear to you? So initially the piston is here. Now just compress this gas a very small value. Now my piston is here. In the another run, my piston is here. In another run, my piston is here. What we are doing? We are compressing this gas, and the deviation from the thermodynamic equilibrium will negligibly small. So we are taking infinitely small steps. If we are taking the infinitely small steps, see, let's suppose the pressure here, it is my, let's suppose it is my 2 kilopascal is my pressure. Infinitely small we compress this gas. So at this stage, let's suppose my pressure is 1.99999. Right? So there is a negligibly change in the process variables. Is it clear to you? Is it clear to you? Right? So we are taking infinitely small steps. So if we are taking infinitely small steps, then we can say, yeah, the deviation in the thermodynamic equilibrium is negligibly small. Means that it is not considerable. So we can say, yeah, thermodynamic equilibrium is established throughout the process. But for that purpose, we have to take infinitely small steps. Right? So in the quasi-static process, the process is infinitely small. Right? And at every condition, at every situation, we can find any parameter. At this stage, we can find pressure, volume, temperature. At every step of the quasi-static process, we can define the thermodynamic properties. It is clear to you? It is clear to you? And throughout the process, we can say that yeah, we are in the thermodynamic equilibrium. I hope that you got my point. Yes, Mohammed, you are getting my point or not? So we can say that this process is infinitely small, infinitely slow, right? So the system passes through a continuous sequences of equilibrium state. Right? Is it clear to you? So the change is so slow, guys, here. Right? So, or we can say that change is so slow. Change is so slow that every moment of system remains in thermodynamic equilibrium. So whatever we calculate the work done, W is equal to PdV, that is, this work done is basically, this formula is basically valid when the process is quasi-static. When the process is quasi-static. Quasi-static means at every point you can define the pressure. It is clear to you or not? Right? So yeah, in the given question there is no need to tell you that yeah, this process is quasi-static. Right? There is no need to tell you. So don't figure out or don't look this word quasi-static in the question कि अगर मुझे quasi-static process दिखेगा तभी मैं W is equal to PdV लगाऊंगा. No, this is only for concept. Yeah, if this is in the question, then yeah, be sure कि quasi-static का मतलब क्या है, and I can think about it and what I can do with this. That's it, nothing else. Right? So ऐसा नहीं है कि आपको quasi-static अगर मतलब if you will see any word quasi-static and you will confuse कि what is this quasi-static. Right? So if the question is saying that the process is quasi-static and this and that at any condition, this is my pressure, this is the value of the volume, calculate the work done. You can apply the integration PdV, that's it, nothing else. Right? You can calculate this directly, there is no problem with that. Okay, am I clear with this? Hanji, yes or no? Can we move forward? Okay. So this is the discussion about the heat. Work done. This is the discussion about the work done. Now we will discuss, guys, about the heat. Right? So there is so much discussion about the heat in the heat transfer chapter. Just we need here the basic information, right? So just put the heading heat. Please put the heading heat and note down the definition. That heat is what? Heat is energy transit which is transferred from one body to another due to temperature difference. Due to temperature difference, right? So heat is nothing but it is energy transient. Means we calculate our calculation is based upon that how much heat is transferred from one body to the another body, right? And when the temperature difference, right? It means that meaning is very simple, that if my temperature is same, then there is no energy transfer or no heat transfer takes place, right? It is clear to you. When temperature is same, then no energy or heat transfer takes place. Heat transfer takes place, right? It is clear to you. And also we already know this, that this is also called thermal equilibrium, right? So if the temperature is same, then we can say both the bodies are in the thermal equilibrium. That's nothing else, right? Okay, so let's talk about the unit of the heat, guys. We already talked about the heat, that this is my path function and all that. We already talked about that, right? Okay. So what about the unit? First unit is basically calorie. What is the calorie? So definition is, it is the amount of heat required to raise the temperature of 1 gram of water, 1 gram of water by 1 degree Celsius, right? It is clear to you. So see, it is my 1 gram. It is 1 gram now. It means that this is the CGS unit actually. I hope that you guys are aware about CGS unit, SI unit, MKS unit, like that, right? In the CGS, G stand for gram, C stand for centimeter, S stand for second. It is clear to you? It is clear to you, right? And a bigger unit of the calorie is kilocalorie. So 1 kilocalorie is nothing but it is my 10 raised to power 3 calorie. You guys are aware about it. These are the basic things, right? So heat is nothing but it is the energy, right? It is clear to you. It is clear to you. Also, work is also energy, heat is also a energy. But the unit of the work done is joule. The unit of the work is joule. And the unit of the heat is calorie. And both the units are related to the energy. So we can compare these two units, right? So here just roughly I compare these units, and in the first law we connect these units, how these units are basically related, and what is the conceptual meaning of the different units, right? So if I will talk about that 1 calorie is equal to nothing but it is my 4.18 joule. Guys, remember this value. This is the important value जो हमें क्वेश्चंस में काम आएगी, right? Or roughly we can say it is my 4.2 joule. If nothing is given if there is nothing in the given the question, then you can take 4.2, or if it is 4.18 it is already given, then you can take 4.18 joule, right? Okay. So 1 kilocalorie in terms of joule is, just multiply with the 1000, it is my 4200 joule, right? It is clear to you? It is clear to you? Roughly value will be 4200 joule. Another unit is BTU, British Thermal Unit, BTU. What is a BTU? It is the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Right? It is clear to you? It is clear to you? So this is basically the FPS system. FPS means in this system, length will be measured in the feet, the mass will be measured in the pound, and time is measured in the second. This is my FPS system, right? And Britishers follow the FPS system actually, okay? And if we connect these units, then 1 BTU is basically 252 calorie. This is the relation between the calorie and the BTU. This is the relation between the calorie and the BTU. Okay. So guys, like the work done, my heat is also a path function, है ना? It is nothing like initial heat and final heat. We always calculate the heat. We always calculate the heat for the process actually, right? For the process actually. So it is a path function. We already talked about it, but just I noted here. It is my path function. Okay, so this is the thing. So see, here I note down 1 calorie is equal to 4.2 joule. 1 calorie is my 4.2 joule. So calorie is the unit of heat, remember, and joule is the unit of work done. Okay. But both Q and W are the energy. So calorie is also the unit of energy and joule is also unit of the energy. But if we specifically say about it, then calorie is my unit of the heat and W is my unit of the joule. These are their own units. ये उनकी खुद की units. I hope that this is clear to you. I hope that this is clear to you. Yes or no? Yes. Okay. Okay guys, so this is it from my side for the today's class. I hope you enjoyed the class. You learned so much things. We have discussed so much concepts today. Okay, and please pay attention here. Please pay the attention in all these graphs. These are important graph guys, right? Please I request you. वैसे तो there is no requirement of any request. It's your work, it's your preparation, it's your future, it's your life. But still, if by making you can say by doing a request, if anybody's life is changing, then it is you can say that very good for me, right? So just go through all these graph, right? Once again, खुद से इन ग्राफ्स को प्लॉट करके एंड वर्क डन कैलकुलेट करने की कोशिश करो, राइट? जस्ट ड्रॉ द ग्राफ्स एंड कैलकुलेट by thinking the concepts and all that, right? and all these things whatever we discussed here. So in the next class we'll discuss about the you can see the free expansion, and after that we discuss guys zeroth law of the thermodynamics. Means by the next class itself we will start the laws of the thermodynamics, right? So okay, thank you so much, bye bye and take care. Let's meet in the next class. Bye bye and take care guys. Thank you.